Hey everybody, so in this video we're going to start talking about roots and radicals. So before we get into the new information, let's review the different types of roots. Okay, so we say that b is the nth root of a if b to the n equals a. Okay, so this might seem kind of strange, but for example, right, we say b is the square root, okay, or second root of a if b squared equals a. Okay, so we actually already know a lot of examples of this type of notation. This is just for other types of roots other than square roots. So it does include square roots. We don't really call them second roots. We normally call them square roots. But this is the same definition that you use for a square root, right? Something is a square root if you square it and get that number back. Okay, so let's look at the notation that we use. Okay, so the notation that we use looks like this. Okay, so we would say this is the nth root of a. Okay, n is the index. Okay, okay, the index tells us the type of root. If we don't see an index, we know that this is a square root. Okay, the most common type of root. So sometimes people will leave out the index too. Okay. A is called the radicand. Okay. The inside part of the root is called the radicand. Okay. And then the whole thing is a radical expression. Okay. And you will hear people leave out the expression part and sometimes just call this a radical. Okay, so the radical is the whole thing. This is the index, and the inside part is the radicand. Okay, all right, so let's evaluate some higher roots. We obviously know a lot about evaluating square roots and about simplifying them, so let's evaluate some higher roots. Okay. Okay, so the index tells us what type of root it is. So here we're dealing with a cube root because the index is 3. Okay, so we're saying what number times itself 3 times is going to give us -8, right? So what number cubed is going to be equal to -8? Okay, so first of all, to get the negative sign, this has to be a negative number, right? Negative times negative times negative will give us a negative. Okay, and then what times itself 3 times is going to be 8? Well, 2 times 2 times 2 is 8. Okay, so our answer would be -2. Okay, here we're asking ourselves what number times itself 5 times is going to be 32. So 2 times 2 times 2 times 2 times 2 is 32. So this answer would be 2. Okay. And then this is what number times itself 4 times would be 625. Okay, if you don't know, you can make a factor tree for 625 to help you. Okay, so you could start with 625. I can tell that this is divisible by 5. Okay, so when I divide it by 5, I get 125. Okay, this is divisible by 5 again. Okay, so it looks like 5 times 5 times 5 times 5 is 625. Okay, so that would mean that the fourth root is 5. Okay, so if you're not sure what the root is, you can always start a factor tree, and that will usually lead you to the right answer. Okay, all right. Now, why are we talking about this together with exponents and exponent rules? Okay, well, they do have a connection. Okay, so we're defining the 1 over n power to be the nth root of x. Okay, and this is as long as they both exist. Okay, so as long as both of these things exist and are well defined, then they are equal to one another. Okay, so let's look at some examples. Okay, so you guys can see from the definition that the denominator of this fraction becomes the index, right? And the base becomes the radicand, okay? So the denominator is going to become the index, and the base becomes the radicand. Now, we don't really need the index in this case because we are talking about a square root. Okay, and we know that the square root of 4 is 2. Okay, so this is how you evaluate these fractional powers like this. Okay, so let's look at another example of this. Okay, so again, the denominator becomes the index. Okay, and then the base becomes the radicand. Okay, so the cube root of 125, well, that's going to be 5. Okay, just a couple more examples of this. Okay, so for part C, right, we can see that our index is going to be 4, so this is going to be a fourth root of 16. Okay, so what number times itself 4 times gives you 16? Well, that's 2. Okay, and here the index is going to be 3, and my base is negative 27, so my radicand is negative 27. So what number times itself 3 times gives you negative 27? Well, it's going to be a negative, right? Because negative times negative times negative will give me negative, okay? And then 3 times 3 times 3 is 27, so it's going to be negative 3. Okay. All right, so here's how you evaluate just numerical values with these fractional exponents. You turn them into a root, and then you give the value of that root. Okay. Let's do an example of just changing between those two forms. Okay. So all we're asked to do here, it says write in radical form, is take this thing that's written with an exponent and change it to be written with a radical. Okay, so we know that the denominator becomes the index, okay, and the base is going to become the radicand. Okay, we're not asked to do anything else here. There's no reason to simplify this or do any other steps. They just want you to change it from having an exponent to showing it with a radical. Okay, so let's try a couple more of these. Okay, so for the second one here, again, the denominator of the exponent becomes the index. Now we know we don't need to write 2 as an index, so we're going to leave the index out. And then the base, which is this whole expression in parentheses, becomes my radicand. Okay. So because this is in parentheses, the whole expression is the base. So the whole expression goes inside of the radical. Okay. Same thing here. This time we do need to write the index because we have a fourth root. Okay, and now because this thing is in parentheses, that whole expression is the base. So the whole expression x plus 3 becomes my radicand. Okay, and now the last part. Okay, I can see that 3 is going to be my index. Okay, now we really have to think about what is the base here. Well, the base of this exponent is just x. So x is going to become my radicand. What does that mean about the 4? Well, 4 is just a coefficient. So 4 is also just a coefficient here. Okay, that tells you the difference between here, where there's parentheses, the whole thing is part of the base, the whole thing goes in the root, versus here where there's no parentheses, just x is the base, so just x goes inside the root. Okay. Now we're going to do one last example where we do the opposite of this. In this one we had exponents and we changed to radicals. In this example, we're going to start with radicals and change to exponents. Okay, so it's the radicand that's the base. Okay, so my base here is 2x. When there's more than one thing, I'm going to put it in parentheses. Okay, and then my index becomes the denominator of the exponent. Okay, again, I need these parentheses because there's more than one piece to the radicand. I have 2 and x, so I need to show that they're both part of the base with my parentheses. Okay. Let's look at another example. Okay, so my radicand here is 2x plus 1, so I'm going to change that into my base, 2x plus 1. Okay, again, it's in parentheses because there's more than one thing in the base. Okay, and then the index becomes the denominator of my exponent. Okay. Okay, now here, the only thing in my radicand is x. So the only thing that's a base is x. And the exponent is going to have 4 in the denominator, so 1/4. Okay, now what do I do with the 5? This is 5 times, so I'm going to put 5 times here, right? It's a coefficient in this expression, so it should be a coefficient in this expression. Okay. One last example of this. Okay, so I can see that my base here is x plus 1, and because there's more than one thing, I'm going to put parentheses. Okay, and the index becomes the denominator of my exponent. Okay, now I have this coefficient of 2, so I'm going to put the coefficient of 2 here. Okay, it needs to be outside the parentheses because the parentheses mark the base, just like this root symbol marks the radicand. Okay, so just like the 2 is outside because it's a coefficient here, the 2 is outside the parentheses because it's a coefficient here. Okay. All right. So everything in this section should be new information about the fractional exponents, other than the very first example that we did about evaluating those roots. Okay, so you guys should be familiar with cube roots and fourth roots, all of that kind of stuff, and evaluating them for numbers. But all of this stuff about the fractional exponents is definitely new information. All right, I hope that makes sense, and I will see you guys soon.